Hello, and welcome back to the Ninox Learning Channel by Ninox Corporation. My name is Andy. I'm a Ninox programmer and trainer. And in this class, we're going to pick up where we left off in our 700.01 class last week when we spoke about table relationships. In that class, we spoke about the one-to-one, the one-to-many, the many-to-one relationship. In this class here today, we're going to look at the many-to-many relationship, that unique relationship between tables where many records in one table can be linked to many records in another table, and that link can be concurrent. Many-to-many records linked to each other at the same time. All of the other links that we've talked about, the parent-child, the stack-to-stack, the one-to-many, the many-to-one, and the one-to-one are all relationships between two tables. The many-to-many relationship is unique in a number of ways, the most notable being it is a relationship between two tables that requires three tables to make operational. We call this the triangulation or the cross-referencing of tables. We call it triangulation because there are 3 points in this relationship, as there are 3 points in a triangle. We call it cross-referencing because we use this third table to define the multiple cross-references or multiple-to-multiple relationships that exist between the two other tables in the data model. Now, to best understand why we need many-to-many relationships, it's often helpful to go back and look at the nature and the operational capabilities of the other kinds of relationships. And for this, I want us to consider this database that consists of, right now, 2 different tables, employees and projects. All the employees work for one company. All of these projects are current work streams that one company is investing in with time and money resources. The idea is that every project has many employees working on it, and each employee can be involved in many different projects. Hence, the many-to-many relationship. Let's look at this relationship using the 2 tables we have today. If we want to establish a relationship between the employees and the projects on which they are working, we can go into the employees table, in administrative mode, go into the edit fields or the table management or data model screen, and establish a relationship that originates at the employee table and ends at the projects table. In the data model, it looks like this. Operationally, however, if we go into the employees table, and let's just select Henry Royce as one of our sample employees. Here we see the employee, and here we see a field that allows us to select a project that this employee may be assigned to. The problem is, now that we've selected the project, there's no way to select another project. Remember, one employee at the same time can be on multiple project teams. So that relationship is clearly not going to work for us. Let's delete it and try going the other direction. If we go to the projects table, and let's say we have a project to put in a brand new accounting system, and we add a link from projects to the employees table, we now see our project, and we can now pop up our list of employees and select one. But again, we now have the same problem in reverse. How do we select a second, a third, or a fourth employee? One of the ways that new users will often solve this problem is by adding multiple links from one table to another. Here we see a situation where I've created the opportunity to have up to 4 people working on this particular project. Maybe we have August Duesenberg, his brother Fred, and Carol Shelby, and finally Enzo Ferrari. And this does work. This does allow us to establish a relationship between one project and multiple team members on the project. And yes, we can go into each employee and we can see on which team they've been assigned. The problem is now we have 4 different links between the employee and projects table. We see that here. And the problem with this is in the employees table, instead of having one embedded table that lists all of the projects, we show all of the links or relationships with one project each. Not only is this inefficient and a very poor user interface design approach, but it is a complete violation of what we call the database rules of normalization. Now, I'm not going to get into the details of these rules of normalization, except to say that the rules, one of the big aspects or major constructs of the rules of normalization is you shouldn't have to do the same identical thing twice in a relational database. We shouldn't have to build the same identical relationship, not twice, not 3 times, but 4 times. And this still would prove inadequate if we have a project that has 5, 6, 8, or 10 team members. So clearly, there is no obvious way to create the many-to-many relationship that we need between the projects and the table of employees who are the human resources that are going to be doing the work on those projects. There is no direct relationship between these 2 tables that's going to work for us. Therefore, we need the 3rd table, the 3rd point in the triangle or the cross-reference. I'm going to create a new table, and I'm going to call this Project Teams. And the only 2 fields are going to be a link to projects and a link to employees. This is a reference field from project teams to projects. This is a reference field from project teams to employees. This one table, project teams, is cross-referencing the records in the other 2 tables. And by doing this, we now can easily and efficiently define the relationships between the employees and the projects on which they're working, the projects and the employees that have been assigned to that team. It's this simple. We go into project teams and we say that the new accounting system has Enzo Ferrari, and the new accounting system has Charles Sykes, and the new accounting system, 3rd member of the team, Fred Duesenberg. The other project, maybe the employee handbook revision, also has Carol Shelby and Fred Duesenberg. Now we can go into the employees table, pull up any one employee, and see these 2 records. These are the project teams to which Fred Duesenberg has been assigned. We just need to go in and make sure that we've put the right columns in, like the name of the project. So here we see that Fred Duesenberg is on 2 different project teams. We see that Carol Shelby is on one team. Eleanor Dodge has not been assigned to any project teams. On the other side of the relationship, we can go to any project and see all the members of that team. Again, making sure that the proper columns have been selected and displayed. Here are the 3 people working on the new accounting system. We haven't assigned anyone to the project of moving into our new office building, but the revised employee handbook, that project does have 2 people. Now, you will note that this person, Fred Duesenberg, is indeed on 2 different projects. The revision of the employee handbook and the installation of the new accounting system. Now our data model looks like this. 3 points. We see the table. This is sometimes called a junction table. We call it a cross-reference table, or that 3rd point, that triangulation table. And if there were a line between these 2 projects, we would indeed be able to draw a true triangle. The shape is not the issue. The issue is this 3rd table enables us to establish the many-to-many relationship that needs to exist between projects and employees. You might need many-to-many relationships if you work in an education environment. One student can be taking many classes. Every class will have many students in the class. You may have this in a healthcare or a legal or accounting or professional services situation, where one patient might have many doctors and each doctor has many patients. In construction, one construction manager might be working on multiple projects, and every project might have more than one or multiple construction managers. The many-to-many relationship is a very common relationship that tends to make people scratch their head or get a little confused in the beginning when building relational databases like we're building here in Ninox. It's very simple. Many-to-many relationships require a 3rd table. Now let's look at some of the things that we can do once we've established this many-to-many relationship. Let's go look at the projects. And we have the new accounting system. There is an option in Ninox to display this type of embedded table as a field. Here we see it as a table. And as a table, we see one individual line representing one record for each member of the team. We can click on that team member's name, bring up that project team member record, and from here, go into the employee and maybe see the other projects on which they're working. If, however, we choose to display this as a field, it now takes up significantly less room, and we can stretch it out. And we now have a single field that allows us to access any of the records in the cross-reference or junction table. Here's the relationship, here's the record that is the relationship between this accounting system project and Mr. Duesenberg. Here is the relationship between Mr. Ferrari and the same project, and finally the project, new accounting system, and Charles Sykes, 3rd member of the team. The difference is, instead of seeing an individual line in a multi-record listing, as we see here, and again, I'll just drag that down again so we can see all 3 team members at the same time. Instead of seeing one line or one record per team member, which tends to create an object in our form or on our screen that is very tall, that takes up a lot of vertical space, we have the option to make it a field and shrink it down so it's a little shorter on the vertical plane, and we can make it as wide or as narrow as we want it on the horizontal plane. Similarly, we can go to employees and do the exact same thing. We can choose to display the end point of the link as a table or a field. Here, as a field, we still retain the ability to look at either record in that cross-reference table, the record that cross-references Mr. Duesenberg to the new accounting system, or the record that cross-references that same employee to the employee handbook revision record. We still have the same capabilities. We could add a third project to Mr. Duesenberg's portfolio. Maybe we also want to assign him to the GDPR compliance review. And now we see, and I'm going to go ahead and get rid of that blank record. Now we see he's assigned to 3 records. And if we go to the GDPR project, we see the 1 person assigned. Want to add a second or a third person? Simply click the plus button or anywhere in the field area. And for this project, we can now assign maybe Ebitcord. I'm going to exit administrative mode, and there we see it. So depending on the user experience and the user interface you wish to create and deploy, you can have these short horizontal constructs or these tall and more narrow vertical constructs. Either way, we see the many-to-many relationship between, in this case, the many projects and the many employees. But what about the other views or the listings of records that we have in the Ninox ecosystem? Let's go in and, while still in administrative mode, add some content to this listing in the project table. I'll click on project name, show column, and I'm going to go into project teams. And from project teams, I'm going to select employees, keeping in mind there's no direct relationship between the project and the employee. We have to go through this cross-reference table. Once in the cross-reference table, I'll select employees and full name. Now at this point, there's a number of things we can do to present the many records that are going to appear in this column, because we are looking at a project that has many people assigned to the operational team. We can concatenate all the names, and this will give us a comma-separated list of last name, first name of each member of the team. We could similarly go through the project team cross-reference table into employees, simply select the ID record and count how many people are on each team. Now there's a little trick that I want to show you when counting records like this. There is no feature or function built into Ninox to hide 0 values. But presenting a bunch of zeros can sometimes make your user interface unnecessarily cluttered, which results in a user experience that is unnecessarily complicated. Let me show you a trick. Let's go in and show another column. But instead of going through the cross-reference table, let's select a formula. And the formula is to count within the project team's cross-reference table how many employees are assigned to this project. Now what I'm going to do is not just count and display the number, but embed the count in an if-then construct. If this number is greater than 0, then display this number. If the count of employees on a project team is not greater than 0, do nothing at all. There is no else clause. And when we do that, we now see the count of employees on every project team that has employees on it, and a blank instead of the 0 on those project teams that are empty, that have no one assigned. This column tends to make the content stand out a little bit more, and the absence of any content implies the 0. So I'm going to go ahead and hide that column. And remember, as a formula, we have to explicitly name the column, so I'll simply name this project team count. And there we go. And we can now put this in descending order to see which project team is the biggest. Or we can look at this in ascending order to see which project teams still don't have anyone assigned. Now, the next thing that I'd like to talk about within the context of this many-to-many relationship is the nature of the relationship between the cross-reference or junction table itself, in this case the project team table, and the two tables that it serves to cross-reference. Right now, we see a relationship between these three tables such that there is a direct relationship between project team and employees and project team and projects. And as we've already witnessed, this creates an indirect relationship between projects' employees. However, note, it is not mandatory or necessary for the third table, that triangulation point or the cross-reference or junction point. It is not required that it be a stack or a data family unto itself. We may in fact go in and make project teams a child of projects. We have a relationship that now looks like this. We could, however, make a case to go the other direction and make project teams a child of employees. Now, whether or not project teams is a child of projects or employees does not matter in terms of the function or role that this third table, this cross-reference or junction table, serves. Whether there is an outer join and we have three separate stacks, whether this is a child of the first table in the many-to-many relationship or the second table in the many-to-many relationship, does not in any way impact the functionality of the table itself. It only affects how records are treated in case of a parent-child relationship when a parent is removed. Now, as I said, many-to-many relationships are simple and they're everywhere. There are so many instances where we need to build a relationship between many records here and many records someplace else. Just remember, this kind of relationship in Ninox or any three-dimensional or relational database requires a third player, an intermediary, a table in the middle that establishes and manages and effectively enables the relationship between the many employees and the many projects on which they work, or in reverse, the many projects and the many employees on each of those project teams. That's the many-to-many relationship. And the many-to-many relationship, more than any other, really allows us to appreciate the benefits of a true three-dimensional relational database system like the Ninox system. That's going to be it for today. This was a pretty quick class, an important topic, a simple topic, and today, a quick topic. I really appreciate you joining me here in this class. I hope you enjoyed it. I hope you learned something. And I hope you'll come back and see us again here on the Ninox Learning Channel, powered by Ninox Corporation. Bye-bye, everybody.